what I want to do is to actively monitor, or get my Taranis to actively monitor my flight battery voltage. Luckily, the receiver I'm using, D2R2, has an A to D converter on it. That A to D converter can measure voltage. However, it can only measure up to 3.3 volts, and I'm using a 3S LiPo, and fully charged that can deliver 12.6 volts. Therefore, we need to put a circuit in between that will reduce the voltage that the A to D converter can see down to 3.3 volts or less. The circuit to do this is called the potential divider, or voltage divider. Our FreeSky receivers, this one's a D4R2, have a telemetry port. These D-range receivers have an A to D port, and this is what we're going to use to measure the flight battery voltage. That plus two resistors. A potential divider or voltage divider is basically two resistors connected in series like that. You apply a voltage to the outside and you get a voltage between the join in the middle and your negative or ground. That voltage between the middle and the ground is proportional to the applied voltage and the two resistance values. So this is what I've already shown you. We've got two resistors. I've labelled them here R1 and R2. We've got our LiPo battery or flight battery, which is connected across the two resistors and provides voltage VI, Vin. And that voltage induces a current flowing across those resistors. This is governed by Ohm's law, V equals IR. The two resistors wired in series, R1 and R2, the combined resistance is just R1 plus R2. So from that we can work out what the current is for a given voltage. That current flowing across R2 means that when we monitor the voltage across R2, we get a reduced voltage VO. We've got various formulas based on Ohm's law, off to the right hand side. The maximum voltage that we want out of this of 3.3 volts, our 3S battery fully charged will give us 12.6 volts. If we were using a 4S, fully charged, not overcharged, would give us 16.8 volts. Lots of information on here. Not going to go into it in any great detail. What we need to do is we need to work out how much we need to divide the voltage by. So our maximum for S3 is 12.6 volts, and we want 3.3 volts out when we provide that across. Now I'm going to round up to 12.6, give myself a bit of a safety margin. 13 volts divided by 3.3 gives us 3.9. For simplicity, we'll take that as 4. So we want to divide the voltage by 4. Our VO, our voltage out, is a quarter of the voltage in. We need to choose two resistors such that VO will give us a quarter of VI. That means that R2 has to produce a quarter of the voltage, or a quarter of the total resistance. R1 has to be 3/4 of that. We want R1 to be 3 times R2. Now we can choose various resistors. If we choose values that are quite low, we'll have a higher current, and that could drain the battery quicker. If we choose higher value resistors, there'll be a lower current, but it could be susceptible to noise from other components in our flight system. Purely arbitrarily, I say the minimum voltage we're going to measure is 10 volts, because once our LiPo goes beyond 10 volts, we are damaging the LiPo. Minimum voltage 10 volts, and at that we want 1 milliamp running. Again, purely arbitrarily chosen. That means that R1 plus R2 is 10 kilo ohms. Again, using Ohm's law. We know that R2 should be a quarter of the total resistance. that's 2.5 kilo ohms, and R1 should be 3/4 of it, or 7.5. 2.5 kilo ohms is not a standard resistance value. 7.5 just happens to be. So we're looking for standard resistance values that will give us approximately 1/4 and 3/4, or one will be 3 times the size of the other. Now, we've got a 2.4K, which is close enough to our 2.5K, so I'll use that plus the 7.5K, and that's what we'll use for a 3S battery. So this is the settings, what I've chosen here. So I've got 2.4 kilo ohm resistor for an S3 pack, and R1 value is 7.5. Using those resistance values and knowing that the maximum we can put in is 3.3 volts, the formula here for the input, the maximum we can have as an input is 13.6 volts. That needs to go into the Taranis transmitter as a range value, and that will be our initial range value. We may need to tweak that because resistors, they're built to a tolerance, so we may need to tweak that. Resolution, that is the maximum RA to D can differentiate for Vin, is 0.05 of a volt, 5.3. Our value for S4, I'm using 1.8 kilo ohms, 7.5. Our maximum voltage that we can measure here is 17.05. The resolution is slightly worse, 0.06. So this is how we wire it up. We connect our LiPo across the 2 resistors. We take a connection between the 2 resistors and put that into the white wire, which goes to the AD2 pin on the telemetry port, and the black wire goes to the ground. So let's wire it up. So this is me wiring it up, and this is speeded up 2 times. So I take the 2 resistors and I twist them together. I then put that into my helping hand and solder the twist together. I then chop off the excess, leaving me about 3 millimeters or so to attach the wire. So I solder on the white wire from the cable that comes with the D2R. It goes to the telemetry port. Note that I've got heat shrink already on this, and I'll slide that over the joint and over the 2 resistors, or partially. I've chopped off the excess there from the other end of the resistors, and I'm now going to solder on the red cable onto the 7.5K resistor. All done. I then have to reposition it. I put the black wire in, line it up to the other resistor. This is the 2.4K, and I'll now solder that into position. Bit awkward soldering the other wire in, and that's the ground on the telemetry port. That's all done. Now I can slide the heat shrink tubing down, cover the joint, and cut off another couple of pieces of heat shrink tubing to go over the other cables and cover the resistors. There we are, all done. Now ready to shrink it. This is my BIX3, and as you see I have already wired that straight into the XT60 connector. It goes on the ESC, and this is the flight test FT22, also with it wired in.
Welcome to Taranis. Motor safe, high expo, low rates.
Right, I'm going to go on to the menu page, and I hit page long press, another long press, and now I scroll down until I get to the range for A2 channel, and we had decided that that should be 13.6. So just scrolling up till we get to 13.6. One, two, three, four, five, 6. There we are. Enter. Now, when I plug in the battery, we see that A2 is now reading 12.53 volts. If I swing this round to the battery, I've got a little meter here, which I'm going to plug in. You can see all 12.5. 6, 2, 3, all 12.5. Swing it around to the Taranis, and it is showing 12.53. So close enough. I thought I might have to adjust the range slightly. Resistors have 5% tolerance, so although I ordered 2.4K, 7.5K, they can vary 5% anyway. So there we are, that's it all set up, and I'm ready to go. At the flying field, to get it to read the voltage, I just need to press the play button when I'm at the model menu. And there we are, I've got 12.32 volts on A2. Now, one final thing to mention is that FreeSky do sell a potential divider board that you can purchase. If you get it from China, it is certainly cheaper than buying 2 resistors from Maplin. My resistors cost 39p each, so 78p for this little potential divider, excluding the heat shrink and the wires. And if you buy it from the FreeSky board from China, it is a wee bit cheaper than that. That's all. Thanks for watching. Goodbye.